Hey, I'm Steve with PageKey Tech. Today we're going to talk about why Git is your foundation as you advance as a programmer. First time programmer 4, let's get into it. So Git is essential. This is like not optional. The more advanced you get, the more you will need something like this, or at least some kind of VC or version control, something to keep track of your code as it changes, because code is infinitely mutable. We can change it in any number of ways, and frequently you will want to change it in different ways, go different directions, maybe come back to square one when you figure out something doesn't work. There's so many different ways that you can change code. You need a special tool to manage it, and that's what Git is. Why will you regret it? Well, have you ever deleted an essay by accident? Or have you deleted a huge paragraph in an essay that you worked hard on, accidentally hit save, and then realized you couldn't get it back? That is not a good feeling. I've certainly had that experience plenty of times. It's one of the worst feelings to lose something that you worked really hard on and now you have to go redo all of that work. For software, it doesn't just feel bad and cost you a couple hours of time possibly. It could cost hundreds, thousands, millions of dollars for some pieces of software that exist, right? Like there's a lot of money, a lot of effort poured into code bases. So there has to be a way to stop that from happening. Git is your foundation. So right here we have a foundation of a skyscraper. Can you get by without it? Sure, in the beginning. But if you're building anything much more than a shed, you're going to want a strong foundation and glue to hold everything together as you build it up from the bottom. Have you ever thought about what it takes to manage millions of lines of code? Some of the biggest software in the world, like your space shuttle programs, your Facebooks of the world, how do they manage all that code? Is that sitting on someone's laptop? Do they keep one copy of that code and manage it very carefully, like it's an archaic text, and cross out little bits and write in new bits and just manage it like it's the only one, it's the Mona Lisa of code? No. Doing so would be a lot like building a house of cards. The higher up you go, the more complex it gets, the more fragile it is. Git, on the other hand, is like taking snapshots of your code as you go. Git, as we'll see, is a tree, and you make commits. So every time you make a commit, you are committing the code base as a snapshot in that moment. So you create a commit or commit your code as you go through after writing some meaningful amount of code. You basically draw a line in the sand and say, here's my code at this exact moment in time, and I made these changes, here's why it's important, and that's it. It's a checkpoint like in Sonic. So you can always come back to that point. So as we mentioned, Git is a tree and you're making commits as you go along, right? So the first time you ever do something, you're going to make a commit, and that's going to be your first snapshot. It's going to be your initial commit. So that's a great start, right? You have your Hello World program. Maybe you're starting a website and it just says, here's the website. You decide to make some changes and then you make another commit. And basically you could do that 5 or 10 times a day, maybe more. So you as an individual make lots of commits, and this builds a very unhealthy looking tree, right? It's just a twig. But at any point you can go back and say, I want to go back to the beginning. Or, oh, I messed up for these previous 3 commits. Let's do something else. So that's one way to think of it. Also, you can get into branching. So say you want to go on a major excursion in your code and you're like, I'm going to add a whole new page to my website. So I'm going to make a branch, and it's going to be called page, I guess. And the main branch is called main or master. So that's this one right here. So you're going to go off and do your page excursion, and you're going to develop some commits there, and eventually you're going to say, okay, I like the page. Let's merge it into master. So you're going to go merge it, and now your master is all current, right? Good. Now, why is this cool? Because at the same time, someone else can be doing the same thing, developing their different page. So they're going down their own little branch. And after you're done, after you've merged your code, you can also merge theirs into master. So you can have multiple people working on different parts of the same code base. And it all works. It's fine. You just have to merge the code at the end. So at this point, when you merge it into the main branch, you just have to resolve whatever conflicts you've created in the various files. So if you're just adding files, it's fine. If you're editing files that other people may also be editing, that's where you can run into issues. Either way, this is kind of your tree visual for Git and how the flow works when you are developing inside of Git. So enough about concepts. How do we actually do this? And can we see this in action? Yes, absolutely. First of all, there's really only a handful of commands that you need to be dangerous with Git, to really get all of the benefit out of it. Pareto principle for sure, 80% of your benefit's going to come from just a few commands, maybe 20% of the commands. Git can get very complicated, but you really just need a few to make it useful. Especially the first two to concentrate on are init. If you're starting a new project, you can initialize a Git repository in this way. And then commit is your bread and butter. That's what you're doing multiple times per day when you are taking that snapshot. Some of the others are fun too. We'll look at those as well. What I didn't include any detail on in this video is how to pull code, push code, fetch code, how to collaborate with others, how to put your code onto a remote server, which is great because then it's backed up. It's on more than one machine at a time. We'll get into that later. For now, just worry about how to use Git locally in your own environment so you can keep track of things and not lose your code. Like I mentioned, you can get really deep into Git and modify that trees in all kinds of weird ways and make a little code tree bonsai if you want. But at its core, you are doing very simple things. These are rote memory tasks that if you memorize just a very short number of things, you get pretty much all the benefits of Git. So let's get into how to use this for real. So let's return to our website from the previous video, which only has a few pages, not too much going on. What if we wanted to protect this source code with Git? Well, you can start with Git Init. That is it. That's all you'll ever have to know about the command, except in very rare situations. Hit enter, initialized empty Git repository in this folder /.git. So you'll see that VS Code picked up on this and it shows all of these files as ready to be committed, essentially. It doesn't show the .git folder, but if you do ls-a, you can see there's a hidden folder called .git. You don't have to worry about what's in there, but that's how Git keeps track of this being a repository. There's really nothing special there other than a bunch of files sitting in the .git folder. That's what makes it a Git repository. So now we can do the most famous flow of commands of all time. Git status, no commits yet, and we see untracked files. We're going to add all of these files to be committed. Before we go any further, let's talk briefly about staging and how that works. So you have your working directory, and this is just all of your files, all your code. You start editing things, and it's red because it's showing things as changed. It's kind of like, whoa, okay, we've changed things, we haven't committed them yet. You can use git add to add it to the staging area. The staging area is really just what is going to be in the commit. It's kind of like if you're taking a picture with your family, you have to get everyone standing in the frame before the photographer can take the picture, right? Everyone has to be standing there, and then you say cheese and you take the picture. That's kind of like this. You're shuffling all the files that you would like in this commit, in this picture, into the staging area. Then you say git commit, and that actually takes the snapshot and it's written in history. Just wanted to clarify before we keep going. When you make changes, they aren't automatically staged for commit. You have to stage them. So you're going to say git add --all. This adds every single file. Git status, we can see that we're about to commit these files, and now we're going to type git commit. We're prompted to enter a message, which is describing the commit, so I'm going to say initial commit. Now your editor here might be Nano or it might be Vim. For me it's Vim. So if you're in Vim, you just hit I to start typing. When you're done, hit escape. And then :WQ to write and quit. Nano's a little different. You can look that up, but I think it's Control-O to save it. Either way, it's besides the point of this video. We just made our first commit. So we can say git log and we see our first commit. Check. Okay, great. Let's delete everything. I'm done with all this. I don't need this website anymore. I'm pretty angry. You know, I'm mad. I'm flipping tables, and I'm like, all right, I just deleted all your files. Everything's gone. We'll do a git status, and we'll say, whoa, you changed all the files. Git diff head is another good one, and you can see what changed exactly. Not only that, you can do git checkout dot, and we're back to where we were. Beautiful. So, I'm going to add a little file called readme.md, and I'm going to say our FTP website, and we're going to say to run python-m/http.server. That's it. That's great info, and you know, that's some meaningful progress. So I'm going to commit it. So we're going to do it again. Git status, git add all. Or maybe you're like, wait a second, I don't want all these files in my commit right now. I just want to do a few that I've modified. Git reset is going to unstage all of the files. So we're back to just readme.md is edited. And let's make a change to index.html just to show this concept. So if you do git status again, now you have two modified files. You only have to commit one at a time if you want. So we did git status. Let's do git add readme.md. Readme is staged and it's about to be committed. So if we commit now, add readme.md, it's telling us readme is about to be committed, index is not. So we commit that, and now if we do git status, we see that it's still marked as modified, it's not been committed. This hello world change, git diff head, shows you, yes, there's still that change, but readme has been committed, and we see it in the log. If you want to check out a previous commit and see what the code looked like then, you can copy this hash, which is a unique hash for each commit. It's like your snapshot ID, and do git checkout and paste the ID. And here we are at the initial commit. You'll notice there's no readme.md. It didn't overwrite our modified file because there was no need to, and we're back. So that's a start for Git. Basically what you need to remember is you modify some files, you say git status, you add all of the files, you git commit, and that's it. You're done. Status, add, status, commit. You can do that over and over and over. As you get the hang of Git, you'll know how to modify things in different ways, how to manipulate things the way you like them, how to use branches, how to collaborate, how to use it. For now, don't worry about it. Just know how to commit code. Hopefully that made some sense. Hopefully you learned something. If you liked it, subscribe. Consider joining the PageKey Tech Discord. Whoa. And that's it. Thanks for watching.